Today's lesson's on reciprocal trigonometric functions, and I sort of feel about these graphs the same way I felt about tan. Was I'd really love for you to understand them, and at some point, it's sort of vital that you do understand the graphs. But for now, if it's a memorization thing, that's okay. But here's a chance. So this lesson's a chance to really, really understand the graphs of the reciprocal trig functions. And we've worked with cosecant, secant, and cotan in the past. We've never really considered what the graphs look like till now. In this lesson, we'll use our knowledge of reciprocal functions along with our understandings of sine, cos, and tan to sketch the graphs of cosecant, secant, and cotan. The immediate question is, couldn't we use a table of values? Well, there's two weaknesses of using a table of values. There's lots of strengths to using a table of values, but the two weaknesses are that you don't necessarily really understand where the graph's coming from and how they relate to the other graphs. The other weakness of the table of values can be time. It can take a long time to produce the graphs using a table of values. Having said that, I'm a big fan of table of values. Table of values have their strengths, and the strength is they'll get the answer. You get your calculator out, you get a table of values built, and you just keep plugging in numbers until you get a good feel for the graphs. So yes, that's there. You can always fall back on that. It just takes a lot of time, especially in a test or an exam environment. But for general homework and stuff like that, it's a great way to handle situations. Okay, so here's the way to do it that gives you a more thorough understanding of the graphs and less time consuming. Let's start with y equals cosecant of x. And to be able to graph cosecant of x, you need to know that cosecant is 1 over the sine graph. So first we need to graph y equals sine x. Oh, it's vital you know sine x. You've got to absolutely have this memorized. And so there I've given you a graph of sine x. Now, y equals sine x is the reciprocal, y equals cosecant x is the reciprocal of y equals sine x. So the graph of y equals cosecant will have a vertical asymptote whenever y equals sine x has an x-intercept. Do you remember why this happens? Well, I'm going to talk about why that happens. I'm going to talk about one specific y-intercept here. I'm going to jump right on and grab, I'll do this in red so you can really see it. I'll grab an intercept at pi here. And at that value, sine has value 0. So if we go to cosecant, which would be 1 over sine, that would be 1 over 0, and 1 over 0 can't be done. So that's where you get your vertical asymptotes. So that really frames cosecant immediately, because every time, and every one of these zeros of sine, and they happen periodically at all these pi values, and at 0, every time you get a 0 of sine, you get a vertical asymptote of cosecant. So if you look right below that, right here, you immediately get some kind of framing of what cosecant's going to look like. Now, sine's still on there. You can still see sine graphed on there. But now the vertical asymptotes of cosecant are on there. So we have some kind of idea that cosecant's going to do, is going to be broken into these sections. Better than that, the sections are going to be very, very repetitive. There's only two kinds of sections here. There's the positive bump in sine, and then there's the negative bump in sine. So once we get one of these figured out, that'll sort of tell us about the rest of the graph. This isn't going to be a long process. So we focus in on one section from 0 to pi here, and I've zoomed that in here from 0 to pi. Now, if you look from 0 to pi, and the graph's already there, it's already given away there, but I want to talk about it, we're going 1 over the sine graph. So when the sine graph has value 1, when you go 1 over 1, you get 1 right back. So that's an easy point to put on there. Cosecant and sine will meet at the 1s. And then we got to talk about what happens as sine heads towards 0. Well, as sine gets closer and closer to 0, we're going to 1 over something very close to 0, which gets bigger and bigger and bigger. When you go 1 over something that's getting close to 0, you get something very large. And if that doesn't make perfect sense, go ahead, get your calculator out and go 1 divided by 0.01, 1 divided by 0.001, and just watch what happens to the answers, and they get bigger and bigger. The notes here explain it as well. If sine's decreasing, then 1 over sine is increasing. And that's very clever, too. I like that, too. I really want you to understand what happens when you go 1 over things that get close to 0. Well, with that thinking, all of a sudden we go, okay, well, as sine goes towards 0, cosecant will head towards infinity. And as sine goes to 0 this way, cosecant goes to infinity. Well, that's enough to do that. I got to tell you, that's enough. Once we understand that part of the thinking of reciprocal graphs, that's enough to get the whole cosecant graph, because it's going to be very repetitive. It's going to do that in every section. You can see that here. It does it there, but here it does it negative side of things, because all of this thinking goes negative. 1 over -1 will be -1, and 1 over small negative values will be large negative values. And so it doesn't take long before you get all the sections come together there, because they're very repetitive. Now, that's the graph with sign superimposed on there. And lots of times, actually, on the first assignment or test you do on cosecant, what will happen is you'll see the sine graph right on people's cosecant graph, because they use a light sketch of sine to remind them of cosecant. I love that when I see it. I'm like, okay, you're really thinking this through. But here's cosecant by itself without the sine graph superimposed on there. Okay, now your task with that thinking. I mean, right now you could just go ahead, look on the internet, do whatever, download some graphs of the other ones, secant and cotan. But I encourage you, before you do that, to try and do that thinking on your own. The rest of this worksheet allows you a chance to first graph cosine. This first graph you'll do here is y equals cosine. I just want to label it on there. And if you label cosine, put cosine of x in there, you'll be able to do the same thing with the asymptotes and come up with a nice graph of secant. That one is very similar to the cosecant one. Then this one, to be able to do cotan, you're first going to have to graph tan. And that's a check to see if you've got tan memorized, or you've got a way to handle tan. And then do the same kind of thinking. It's a little more difficult. The hint I'll give here is, if you're going 1 over something that's going close to 0, it gets very big. But if you're getting 1 over something that's getting very big, then that's going to head towards 0. So that one's a little more difficult. You might need a hint on that one to check what the actual graph of cotan looks like. And then there's some analysis of those graphs to do. Once you've got the graphs done, you got to do some analysis there, okay? And of course, you can check those answers. There's a completed version of this online, so you can totally look when you're done and see how you did. And it's really just about getting to know them. So don't worry if you don't get all the features exactly right. Try it again after you see the actual graphs and go after it. And there's not a big load of homework for this. It's just getting to know those graphs. For the assignment or tests, for whatever, for this chapter, you just have to know the basic secant, cosecant, cotan graph, however you decide that you're going to be able to produce those graphs. Nothing too crazy there.